The last time we learned how to graph quadratics was when we were doing it in vertex form. I don't want you guys to write this. I just want to refresh your minds a little bit. Like we learned how to graph this, for instance. So don't write this, just watch. It's a quadratic. How do I know it's a quadratic? It has that little 2 there, right? So right there, that's how we know it's a U shape. So now we know, okay, now I want to look for my vertex, which is 4, 5, right? And then this tells me it's a sad face parabola. So I would graph my vertex, and I'd make a sad face parabola. And that's how we did it when we had vertex form. But when you're doing standard form... Oh, you're right. +5, huh? Darn it, John. You're a genius. It just amazes me. I do owe you a point. I do owe you a point. I will get you. You're actually a pretty smart guy.
That's funny.
I think
that's a good joke. Is that our math joke?
Anyway, so when it's in vertex form, it's kind of easy to find the vertex. The problem is when you're looking at a quadratic that's in standard form, getting your vertex is a little weird, okay? It's not just there to look at anymore, so you got to find your vertex. So here we go. I'm going to give you guys some notes first, and then we're going to actually do it. So part A, how to find the vertex in standard form. How to find the vertex in standard form. Okay, so step 1, I think I'll write it as a step. Step 1. Step 1 is to find x. Remember, a vertex is a point. It's an x and a y. So the first thing we're going to do is going to find x. And the way that you do that is with a little formula that somebody came up with. If you did the extra credit video that I assigned you guys on Wednesday, this will look familiar. And it's actually part of the formula. It's x is equal to negative b over 2a. That's where it comes from, that extra credit assignment. I don't know if you guys remember, it's the one in parentheses was x minus b over 2a. That's the h part of your vertex. So there it is. And if you guys are wondering what a and b are, remember standard form is like this, right? So b would be this number here, and a would be going there. And that will find you the x part of your vertex. Step 2, to find your y, is our second step. Find the y. The way you do that is you plug your answer into the equation from step 1. Okay, so step 1, find your x of your vertex using that little formula over there. Step 2, find your y by plugging that answer into your equation up at the top. Okay, so I'll let you guys pause and write that for a little while, and then we'll actually do one joke for you there. Okay, are we ready? Let's proceed. So, example 1. A hug.
My birthday is Halloween.
I know, my birthday's in 6 days. Oh, good. We get it, you're butthurt. Jesus Christ. Wait, hold on. Who stood up for me over there?
Joanne.
Aw.
That like hardly happened.
Joanne, you get a real eagle card.
Woo! Wait, what?
Wait, just like anti-bullying.
Protecting me,
You
Captain.
give it to like somebody at the front office, and then you get candy or something. All right,
Can I get one? I deal with too much in this class.
Okay. You guys ready? Okay, now pay attention. Ready? We're going to find the vertex for this thing. So here we go. Step 1 is to what?
Find the x.
Is to find that x. And the way we do it is we do negative b over 2a. What's the b?
2 what?
Try again. Negative 2. Right? This is the b. What's the a?
1.
1. When there's nothing in the front, you can assume it's a 1, right? So here we go. I've got negative 2, which is positive 2, over 2 times 1, which is 2, which simplifies nicely into 1. So that's the x part of our vertex.
Then we have
Okay?
to find the y.
Now we need to find the y. That's step 2. And to find the y, all you do is you plug it in up here for x, and that will tell you the y that goes with it. I don't think so.
Are you slow?
You didn't write down the negative from the -2.
Well, the formula gives us a negative, right?
Oh.
And we're plugging in a negative, so the double negatives cancel. Okay, so step 2 is to find your y by plugging your answer in for x, right? So it's going to be x squared minus 2 times x plus 3 equals the y. So my x is 1. Square the 1 first. Multiply these. 1 take away 2 is negative 1. And then negative 1 and 3 makes 2. Oops. So I end up with 2 as a final answer. And here's what I'd like you guys to write for your final answer. It's a point, right? What's the x value?
1.
And the y value? 2. So this is my vertex. Now you guys notice I called this part A? Because I'm going to add a part B now.
I have a question.
But go ahead. Yeah, just a second. Go ahead, Kayla.
Oh, never mind.
Okay.
This is the -1. Never mind.
Okay.
Never mind.
We good? Okay. Now, that's what I really wanted you guys to get, but I'm going to throw something else on because I think you guys can handle it. We're going to graph it now. Okay?
No.
It's just putting the function.
It really is. It's just putting the points. So let's add part B, and we're going to put graph it now. So to graph it, you guys, you need to know 2 things. You need to know whether it's a happy face or a sad face, and you need to know where your vertex is. We just found the vertex, right? I'm going to rewrite my equation because I can't see it anymore. But anyway, my vertex we just found out was 1, 2.
Yes.
And now, is it a happy face or a sad face? We do, actually. You can.
It's a happy face.
It is. You still look at the number in the front. So since that's a positive, it's a happy face. So remember, if A is positive, it's up. If A is negative, then it's down. So in this case, my A is positive, therefore we have a happy face parabola. So we're good to graph this. I'm going to go over 1, up 2, and I'm just going to sketch a rough happy face there. I smelled it.
Yeah, it's like a normal slope that you did want.
The slope?
Yeah, it's the slope.
We don't have to find the slope, do we?
So remember, quadratics don't have a slope per se. So, because it's constantly changing.
It's like, is the A still just what?
It does the same thing as, yes, it's literally the same exact number.
Are we going to have to find the minimum or the maximum?
I could ask that. I don't plan on doing that today, but could. Right? This is a minimum, and the minimum is 2. We could do that.
Then it just ruin your whole plot.
No. Just makes me want to add a part C. So part C, just kidding. All right. So here's one for you guys. Let me throw one up. Y equals 3x squared minus 12x plus 5. I want you guys to do two things. I want you to find your vertex first, and then I want you guys to graph it after that. And you know what? I'm going to put a negative there, just because I can. So, go ahead and find the vertex and graph it. Because there's a few people in here where I've noticed that I'm going a little bit too slow for you sometimes. So if you want another problem where you can kind of, this is just a basic idea, but if you kind of want to see some weird things that could happen, consider doing this one and see what might be irritating about that. Or I'll call these bonus problems if you get time. Well, I wouldn't say something goes wrong, just something that would maybe be a little perplexing, but nothing that you probably couldn't just work your way around if you're ready for it. But I want to make sure everybody gets number 1. So if I'm boring you with number 1 and you got it already and you want to jump down to 2 and try that, you can. Did you get your vertex? I like your -2. All right, so, but the next one's off. So everybody knows how to do the problem fine. The problem is we're having issue with like multiplications and negatives out there, but as far as the algebra goes, you guys are doing okay. So to begin with on this problem, first of all, notice that the formula gives us a negative, right? It's negative b over 2a. Now my b is a negative also, so you got a double negative there, and my a is also a negative. So these negatives cancel. So you're left with a positive 12 over negative 6. So you should have had a -2 there. Okay. Then we get to do the fun part of plugging it in. So let's see if Javier, what did you get for your y value? 17. The answer was 17. I saw a few like 7s out there. A 31. A lot of things could go wrong, but let me show you how to calculate. So the first thing you would have done is you would have plugged in a -2, right? So that's error number 1. Make sure you got the right x value. If you don't have the right x value, then that would explain why you got the wrong number there. But we're plugging in a -2. Now the first thing you're going to do is you're going to do this square. -2 to the second power is what? 4. And then these two things multiply together to make a positive 24, because double negatives make a positive. This is -12. And then from left to right, -12 and 24 makes 12 plus 5 is 17. So there's your vertex. And then for graphing, we're going to go left 2 and down 17. I'm going to cheat and just pretend I went down 17. But your vertex would have been somewhere down there in that bottom left-hand third quadrant. No, it isn't. My bad. I graphed it wrong. So it's the second time I did it today. Left 2, up 17. So your vertex would actually be up there. Yes, you're correct. And speaking of, I just pulled Rowan's card. So Rowan, happy face or sad face? Sad face because the A is negative. And there you go. All right?
Why are all of our graphs sad?
Because it's bad.
And there you go. Okay. All right, so I'm going to answer these two really quick in case anybody saw fit to do them. So on this one, the issue is the following thing. -b over 2a. The issue is you end up with a fraction or a decimal. And so my advice to you is when you have to plug it in to find your y, just use a calculator. Yeah. No. Just as long as you have a negative on the top or the bottom, you're good. Just don't do it in both spots. All right. The other issue here I'm not going to finish the rest of it, but as for number 3, the issue here is there's no what? There's no b. So if there's no b, then it would be 0. And so guess what x turns out to be? Just 0. Anytime the top of a fraction is 0.
Oh, so it's -8.
There you go. So actually, whenever it's like this, when you have no b, the vertex, you actually can just see it. It's 0 and whatever that number is. Okay? All right. Anyway, I want to do a little bit more. I want to talk about something else. Let's talk about part B here, how to find the y-intercept. How to find the y-intercept. Okay, I owe some points and I haven't been writing them down, so I'm going to write them down really quick. I had John earlier, right? And I had Rowan. What else, though? I had somebody else do something.
Mr. Bailey, come look at this.
I'm going to go ahead and finish what I'm talking about first, and then I will.
Can I just lift it up so you can see it?
I guess, dude.
Look at my children.
Look at your
Hold on. Just so we can see a bird done in my life. I don't care.
That's cute, man. Are they clay?
No.
Oh. Okay, now bonus point again. How do you find the y-intercept?
GG. What?
How do you find the y-intercept?
plug in 0.
There you go. Plug in 0 for x. Okay, so let's take this one for instance. X squared plus 3x minus 5 equals y. Well, if I plug in 0 for x,
It'll be -5.
yeah, you don't even really need to do any math, right? Because what happens here?
That's 0. That's 0.
All these things just go away, and you're left with -5. All right, so from now on, shortcut, to find your y-intercept in standard form, the y-intercept is that guy. So you really don't need to do the thing where you plug in 0 when it's in standard form. Because if you do plug in 0, it's just going to get rid of everything with an x, and all you're going to be left with is a c. All right? So this isn't a big deal, and you can kind of get by today without doing this, but now that we know how to find the y-intercept really easily, I'm going to show you how you can get a little bit more of a precise graph now, and then we'll call it a day, okay? All right. Because we're just kind of fudging it. We're like happy face, sad face, but now that we have a y-intercept, we can get a more precise looking graph, okay? And really, you can always get a more precise looking graph by just plugging in more numbers and getting more points over and over again. Are we good?
Yeah.
Last problem for the day. Ready?
Wait, it's almost.
Yeah, we're finishing a little early. So example 2. My directions are going to be graph.
These are still on that? Yes. Chill out.
Wait, we're done for the day after this?
Yeah, I'm going to stop here after today. You're welcome.
Why? Why so little?
Because we're done. Okay, so if I wanted to graph this, you guys, what's the first thing I need to do? Vertex. And if I want to find the vertex, what's the first thing I need to do?
Find x.
Which is done by doing?
Plug in 0 for y. Wait, nah. Yeah.
Negative b over 2a, right? Which is going to be 8 over 4, which is 2. Now what do?
You have to find y.
Plug it in.
You find your y by plugging in your answer.
So you plug in x for 2. No, 2 for x. Really? Yeah.
You're right. Exponents are first. Then multiplication. And then this is going to be -8 plus 5, which is -3. I'll pause for a second because I know I'm going a little bit fast, but that's just all review stuff. So find your x, plug it in to find your y, right? So technically, we do have enough information to graph this now. I've got my vertex. It's 2, -3, right? And we know that it's going to be a happy face. So technically, we could graph it. But since we have a we can find something a little bit more specific now, can't we? Let me box this off. So this is my vertex, right? But we can also identify our y-intercept really easily. What's my y-intercept? It's that guy, right? Because if you plug in 0, these two things just go away and you're left with 5. So my y-intercept is when I plug in 0 for x, I get 5 for y. So I have over 2 down 3 is my vertex, right? My y-intercept is 5, right? Now we know it's a happy face, so it's got to go like this. So now I know it's got to go through that dot and this dot. And since parabolas are symmetrical, you can imagine there's got to be another one over here somewhere, right? So just kind of do that. And now your shape's a little bit more precise. So by knowing where your y-intercept is, you can actually know a little something more about the actual width of your graph and stuff like that, which also helps you get better estimates of what your roots may be and things like that. So that's the benefit of knowing how to find the y-intercept, just plugging in 0 for x. Okay, so that's that. The what? This other point? Okay, so you know what symmetrical means? Symmetrical means like if the left side is like the right side, like my hand. Symmetrical, right? Or my face. Left side is like. So same thing with your parabola. This side is like the reflection of this side. It's like if you folded it in half, they'd match. So if you've got a point over here, then there should be a point over here that's like opposite from it, because it's symmetrical. All right, we're good. We'll call it a day.